Design of a rectangular concrete beam in accordance to NSCP 2015. Hello everyone, this is De La Cruz Engineering Video Tutorial. So as the title shows, we will design a reinforced concrete beam specifically on flexure. Okay, these are the topics included. So without any further ado, let's start to solve a problem. So rectangular reinforced concrete beam has these strengths, service loads, and it is stated the compression reinforcement, if necessary, will be placed 70 mm from the extreme concrete compression. Okay, before that we will start the part A. Okay, what is the value of the maximum steel ratio when the beam is singly reinforced? Okay, we will use here the updated NSCP. Hindi na ito katulad sa NSCP 2001 na kukunin yung row max, then it is based at 0.75 of the row balance. Okay, here in NSCP 2015, ito yung sinabi sa code. For non-pre-stressed beams with PU is lesser than this limitation of 0.1 of FC prime AG, and the strain shall be at least 0.004. Okay, disregard na lang this inequality because wala naman tayong axial load dito sa beam. Okay, ito na yung let's focus on the strain at least 0.004. Okay, if we are to draw the strain diagram dito, ito yung mangyayari. Okay, sinabi sa code na the strain of the steel reinforcement shall be at least 0.004. Okay, so mathematically expressed as ganito. Okay, the strain epsilon t must be greater or equal. Okay, and according to this section, the maximum strain of the extreme concrete compression fiber shall be equals to 0.003. Okay, so dito yan. The strain daw dito is 0.003. Assume yan. Okay, that is the assumption of the code. So this will be our strain diagram. Okay, now ano yung gamit dito? Ganito yan. At this portion where the strain is 0, this will be the location of the neutral axis from the extreme concrete fiber, and that is denoted as C, small c. Okay, now we can create a right triangle here, and we will try to isolate that. So this portion here is just the sum of these strains, and we will call that as epsilon sum, that is greater or equals to 0.007. And this is C, and this is 0.003, and this is the effective depth. Okay, as you can see, we can create we can use the similar triangle theorem or the ratio and proportion. D is to this epsilon sum and C is to 0.003, and equating this in terms of the epsilon sum, ito yung lalabas. Now, satisfying this equation, or inequality rather, ito yung magiging inequality natin. Okay, the epsilon sum is ito, 0.003 D over C. Okay, now cross multiplying, C can be expressed as ito, 3D over 7, and C should not exceed this value. Therefore, we can also say that that will be the C max to be used, that is 3 over 7 of D, and ito yung formula, okay, in maximum condition according to this code nga. Okay, then susunod dyan, makukuha natin yung A max, which is beta 1 C max. This is also in the code. Okay, papakita natin ito mamaya. Okay, after that, how to solve the AS? So ganito yun. This is the cut portion of the beam, and this is the area of the steel reinforcement inside view. Okay, projecting that, ito yung C, and that is the neutral axis, and the portion below the neutral axis is the tension of the concrete. Now, the tension of the tensile strength of the concrete is assumed to be negligible. Okay, nini-neglect natin iyan sa reinforced concrete design. Okay, kaya i-cut natin yan, and this will be the depth of compression block A. Okay, and that is just beta 1C, and that is given in the code, which is dito. concrete stress of 0.85 FC prime, and so on and so forth. So ito lang yung ibig sabihin yan. The stress daw dito is uniformly distributed, and the stress is 85% of the FC prime. Okay? So as you can see, it will create a resulting force dyan. Tatawagin natin capital C. That is the compression of the concrete. And of course, to maintain equilibrium, ito yung ika-counteract ng tension steel. Let's call that T. Okay, according to this section, ito yung sa beta 1. Beta 1 is nagbe-base sa FC prime, sa value ng FC prime. Well, as you can see, FC prime is 34 megapascal and it follow this criterion. Okay? It is greater than 28 and lesser than 55. Therefore, our beta 1 here must be solved through this equation. We substitute the beta 1, I mean the FC prime. Beta 1 is yun. So, mas advisable na i-store mo yung values dito, no? Para, the answers talaga is saktong-sakto sa choices, lalong-lalo sa board exam. Okay. Now, after that, we will use the derived formula kanina for Cmax. And ito yung makukuha. Then, susunod yung Amax dyan. Okay? So, ito yung lagi nyong tandaan, no? Sa concrete talaga, unang-unang hahanapin natin is yung C, then susunod yung A, or vice versa, mauna yung A and C. Yan talaga yung step sa concrete. Okay. So, that is that value, 166.03. After that, we can equate T is equals to C for equilibrium equation. And that is just ASFS, force times area. And the same dito, stress times area. This is the stress, this is the area. That is the rectangular section dito. Okay? So, Fs, ano yung Fs na gagamitin natin dito? Okay, take note. We are in this strain, 0.004. And recalling the Hooke's law, stress is equals to Young's modulus E times strain. Okay, now using that, in terms of steel, let's call that Fs is equals to E times strain. Now, the modulus of elasticity of a steel is 200,000 MPa. And using that, Fs corresponds 800 megapascal. Okay. Now, that Fs exceeds the yield strength Fy ng ating steel. So, we cannot use this. Lumagpas siya sa limitation ng kaya ng steel lang, kung saan mag-yield na siya. Therefore, we will use here Fs is equals to Fy. Okay? Then, substituting this, we will cross-multiply this Fs dito sa baba, and Fs is equals to Fy. And substituting all the values, ito yung makukuha natin, maximum steel area. Okay, this is for NSCP 2015. Okay. Now, let's proceed to letter B. Given yung service loads and factor loads, okay, and compression reinforcement F necessary will be placed 70 mm from the extreme concrete compression. What is the required tension steel area in millimeters squared? So, ano yung gagawin mo? Take note mo na, ha? This is the nominal moment capacity, and this is the moment arm, D minus A over 2. Okay, D minus half ng A kasi nag-aak yung concrete. Okay, that is equals to C times D over 2 yung moment, or equals to T times D over 2. Kahit ano yung force yung gagamitin mo yan, equal lang yan. Okay, now, let's solve first the required moment or the factored loads. Okay, this is the governing factored loads, and ito yung just substitute the moment here. Okay, dead load and live load, and the required moment mu is 450 kilonewtons meter. Okay, now ito yung criterion na dapat masatisfy. The design moment, the VMN must be equals or greater to the required moment. Of course, para hindi masira yung beam, dapat mas malakas yung capacity. Now, the question here is, hindi pa natin alam if i-design natin to na singly reinforced or i-design natin siya as doubly reinforced. So, the question here is, what is the boundary of the singly to doubly reinforced? Okay? and NSCP 2015. Okay? Take note, magkaiba ito sa NSCP 2001. So let me show you these provisions. So these are the provisions. This is for the limiting strain, and this is for the reduction factor that is in the code. Okay, this table is hindi ito yung actual na nasa NSCP 2015. So sinimplify ko, neglect ko yung mga unnecessary tables. Okay? Ito lang yung magagamit talaga natin sa lalong-lalo sa board exam. Okay. Now, we will draw this in graphical representation. So this is the reduction factor P represents y-axis, and this is the strain epsilon T represents the x-axis. So ito yung line niya, I mean the curve mismo na sinasabi dito sa code. And this is representing the 0.65 reduction factor, and that will corresponds to the strain epsilon Ty. Okay, from here. So if the epsilon T is lesser to epsilon Ty, our reduction factor is constant, 0.65. Now, this part naman will represent this reduction factor, I mean this strain, 0.005. Okay, and it says here that if epsilon T, the actual strain of the stress, I mean this steel, is greater to 0.005, that is tension controlled, and our reduction factor is constant to 0.9, and that is the very advisable sa design. Dapat gamitin natin yung 0.9 to ensure ductility. Okay, now this is the compression controlled here, this is the transition zone, and this is the tension zone. Okay, ito yung pinaka-advisable na gamitin. Okay, now additional sa code dito, for the form reinforcement, epsilon Ty shall be Fy over Es. Okay? For grade 280 deform reinforcement, it shall be permitted to take epsilon Ty to 0.002. So this says lang na if yung Fy natin is 280 megapascal yung yield strength. So that is very rare na gagamitin natin for main reinforcement. Okay? So ito talaga yung kadalasan natin ginagamit. Therefore, this epsilon Ty can be expressed in steel Fy. And this can be expressed in 1000 MPa. Okay? I-multiply mo lang sa modulus of elasticity ng steel na 200,000 MPa. Okay? Now, itong 0.004 is somehow, teka muna. This line pala represents this formula. Okay? This line is the, ito yung equation ng line na yan. That is, P is 0.65, but I will express here as in terms of stresses. Dito is expressed on strain. Kasi mas madaling tandaan pag stresses kasi. Okay? So, look at this. Epsilon T is the actual stress. Epsilon Ty is Fy. 0.005 represents 1000 MPa. And Fy represents epsilon Ty. Okay. Now, we will plot this 0.004 dito. So, it is somehow dito. Lesser than 0.005. So, ano yung ibig sabihin dito? So, ganito yan. When Fs exceeds, teka muna, we will express this also into stresses. Ito yun, no? And pinakita natin kanina. This can be expressed as 800 megapascal. Okay, so ito yung gusto kong i-emphasize. When Fs daw is greater than 800 megapascal, or in terms of stress, I mean in strain, is greater than 0.004, it can be designed as singly reinforced. Otherwise, it will be designed as doubly reinforced. Okay? But as we can see here, the range of the strain from 0.004 to a less than of 0.005, so the range here, or in terms of stress from 800 MPa to a less than of 1000 MPa, the reduction factor is not constant and is variable. So dito yun, ang reduction factor mo is not constant and is variable in terms of stresses or in terms of strain. So, hindi siya pasado sa reduction factor na 0.9. Okay? Now, for the simplicity of the design, it is advisable to use the reduction factor as 0.9 to ensure ductility. Ang susunod dito na dapat ang strain ng steel should be greater to 0.005 if we will use 0.9, of course. Or in terms of stress, Fs should be greater or equals to 1000 megapascal. Therefore, the conclusion here is we will use as the boundary of singly reinforced ang strain na 0.005 or the Fs as 1000 MPa. Ito yung magiging boundary natin because it both passed the code provision na ito, 0.004, and the fixed reduction factor na 0.9, okay, which is the very advisable for design. Okay, for the summary here is ito. When Fs is greater or equals to 1000 MPa, we will design the beam as singly reinforced. Otherwise, we will design that as doubly reinforced. Okay, so recall this where Fs is 600D minus C over C. So it is derived from the stress strain diagram rin. Okay, now let's proceed dito. Okay, ano yung gagawin natin? Assuming tension still yields and tension control where Fs is 1000 MPa, and we will use fixed reduction factor na 0.9. It is the very advisable, di ba? Okay, using this criterion, we will express this is in Rn(bd squared). This is the very simplest way to solve rectangular beams, okay? Design rectangular beams. Ito yung pinaka the best na gamitin. Now, i-cross multiply natin yan, makukuha natin Rn. And ito yung values, substitute lang. Mu is, gawin natin newtons millimeter. And the dimensions, reduction factor, and Rn is 7.234 megapascal. Okay. Now, after that, we will use this formula for rho. Okay? Then, i-substitute mo lang lahat yung given datas. And our rho actual is 0.020477. Then, after that, we can solve the AS, that is rho BD. And substituting all the values, our required steel area is 2949. Okay? So, after this, we must pass this criteria na dapat hindi siya bumaba sa AES minimum. This is for cracking sa concrete kasi. Okay? So, let me show you this using our calculator. It is stated here that AES mean shall be the greater of A or B. So, disregard this portion na lang ha. Kasi ito is for T-beams. Dadating tayo sa T-beams. Okay? So, using our calculator, we will solve that. And 0.25 square root of FC prime, I will let that as our variable. And Fy, Y. And BD. Okay. Next, this equation naman. 1.4 divided by Fy, then BD. Ayun. Okay? So, I will press calc. Ay, mali. Okay, I will press calc and see that is the FC prime, 34. And Y, that is the 414 megapascal. B is 300. Our depth is 480. Okay, so this is the first value, 507. Now, this value is 486. So, letter A will be the greater. So, ito yung gagamitin natin as A max. Okay, this is 507 yung A max natin. Okay, so as you can see, our required tension steel is greater to AES minimum. So, that is okay. Hindi siya bumaba dyan. So, we pass this criteria. So, ang ipoprove na lang natin dito na kung if for singly reinforced ba siya or hindi. Ito yung ipoprove natin, di ba? Okay. So Fs is 1000 MPa ito. So anong gagawin natin? We will let Fs is equals to Fy because hindi dapat lumagpas yung strength natin sa yielding strength. Okay? Because Fs natin dito is 1000 MPa man. Okay. So equating compression and tension, so 0.85 Fc prime and AS Fy. So here we can solve our A dito. Substitute nyo na lang yung mga values or pwedeng gamitin yung shift solve. And our A here is 140.817. Then susunod yung C dyan. A over beta 1. Okay? So that will be the value. Now, i-check na natin yung actual Fs dito. Where Fs is ayan, that formula. Okay? Dapat ma-memorize nyo talaga ito Pwede naman siyang ma-derive but masyado nang hahaba yung time na pagsosolve mo. Memorize nyo lang talaga. Okay? Then substitute. Then Fs is 1050.7 megapascal. And that is truly greater than 1000 MPa. Therefore, that is correct. Our solution from the start is correct. Okay? And it is designed for singly reinforced. So, our AS dyan is yung nakuha natin na AS required. That will be the answer. Okay? So, otherwise dito, if nag-lesser than siya sa 1000 MPa, de-design natin siya using doubly reinforced na. Okay? So, I hope na intindihan nyo lang yung presentation natin. Okay? And if you haven't subscribed yet, please subscribe to my channel and share my videos to your CE friends also. Okay, thank you everyone and God bless and please stay safe always.